Hello dear friends, welcome back to my YouTube channel Chemistry Aspirant. In today's lecture, we are going to learn about the types of hybridization. We know that hybridization is a concept which is useful to explain a bonding in molecule, particularly the covalent bonding in the molecules. So now in today's lecture, we are going to learn types of the hybridizations that we have observed during the formation of molecules. We will know about the definition of the different types of the hybridization along with the geometry and the bond angle which is present in the molecule after the hybridization process. So now, depending upon the type of atomic orbital involved during the mixing and the recasting process, that is nothing but your hybridization, generally the hybridizations are classified as a Sp3, Sp2, Sp, then Sp3D, Sp3D2 and Sp3D3. So in this lecture we will going to define each type of the hybridization along with their geometry and the bond angle. Now let us consider the first type, that is Sp3 hybridization. Now let us define Sp3 hybridization. The process of mixing and the recasting of an 1s atomic orbital and 3 p atomic orbital of a same atom having nearly same energy to form a 4 equivalent hybrid orbitals with equal energy, identical shape and a definite orientation in a space. Now this process is called as an Sp3 hybridization. So now here you have to just remember one important thing: a 1s atomic orbital and the 3p atomic orbital combined to form 4 Sp3 hybrid orbitals. So now in the Sp3 hybridization, generally the geometry is tetrahedral. The bond angle which is present in between this hybrid orbital is 109 degree 28 minute. And if we consider the percentage of the atomic orbitals involved during the Sp3 hybridization, the percentage of a S character is 25%, the percentage of a P character is 75%. And you can observe in the diagrammatic representation, after the hybridization process, these 4 Sp3 hybrid orbital arrange in such manner so that they have minimum repulsion and a maximum stability. So here you can observe that these 4 hybrid orbital arrange in the tetrahedral manner. So this is about the Sp3 hybridization that we have considered. Now let us define the second type of hybridization, that is Sp2 hybridization. The process of mixing and the recasting of a 1s atomic orbital and the 2p atomic orbital of a same atom having nearly same energy to form the 3 Sp2 hybrid orbital with equivalent energy, that is equal energy, identical shape and the definite geometry in a space. Now this process is actually known as an Sp2 hybridization. So now in the Sp2 hybridization, the 1s and the 2p atomic orbital combine to give the 3 Sp2 hybrid orbitals. Now if we consider the geometry of Sp2 hybridization, generally the geometry is trigonal. The bond angle is 120 degree between the hybrid orbitals. The percentage of a S character is 33.3% and the percentage of a P character is 66.6%. And now you can observe that these 3 Sp2 hybrid orbitals arrange in the trigonal manner. So this is about the Sp2 hybridization. Now let us define the third type of hybridization, that is Sp. The process of mixing and the recasting of a 1s atomic orbital and the 1p atomic orbital of a same atom having nearly same energy to form with the 2 Sp hybrid orbital with equal energy, identical shape and a definite orientation in a space. Now this process is known as an Sp hybridization. So now in the sp hybridization, the one s atomic orbital and the one p atomic orbital combine to give the two sp hybrid orbitals. Consider the geometry of sp hybridization. It is linear. Bond angle is 180 degree between the two hybrid orbitals. The percentage of a s character is 50% and the percentage of a p character is 50%. Now here you can observe in the diagram these two hybrid orbitals arrange themselves in the linear manner or in the straight chain manner. Now let us consider the fourth type of hybridization, that is Sp3D hybridization. So now let us define the Sp3D hybridization. The process of mixing and the recasting of a 1s, 3p and the 1d atomic orbital of a same atom having nearly same energy to form a 5 Sp3D hybrid orbital with equal energy, identical shape and the definite orientation in a space, or this process is called as an Sp3D hybridization. Now here 1 s atomic orbital, 3 p atomic orbital and the 1d atomic orbital combine to form 5 Sp3D hybrid orbitals. If we consider the geometry of the Sp3D hybridization, it is trigonal bipyramidal. You can observe in the diagram. So the three hybrid orbital arranged in a one plane in a triangle, while the two are above and below the plane. The bond angle is 120 degree which is present in the plane, while the other bond angle is 90 degree which is above and below to the plane. An example is PCl5. Now here you can observe that the 5 Sp3D hybrid orbital arranged in the trigonal bipyramidal manner, in which the three hybrid orbitals are in a plane. Two hybrid orbitals which are remaining will arrange themselves above and below that plane. Now let us define the next type of hybridization, that is Sp3D2 hybridization. The process of mixing and the recasting of a 1s, 3p and the 2d atomic orbital of a same atom having nearly same energy to form a 6 Sp3D2 hybrid orbital with equal energy, identical shape, the definite orientation in a space is called as an Sp3D2 hybridization. Now here the 1s, 3p and the 2d atomic orbitals of a same atom combines to give a 6 Sp3D2 hybrid orbitals. If we consider the geometry of Sp3D2 hybridization, it is octahedral. The bond angle is 90 degree. Example is your SF6 molecule. Now here you can observe in the diagram, out of these 6 Sp3D2 hybrid orbital, 4 are arranged in a one plane in a square manner, while the remaining 2 hybrid orbital arranged above and below plane, and this leads to the formation of your Sp2D2 hybridization. Let us define the next type of hybridization, that is Sp3D3 hybridization. So what is Sp3D3 hybridization? The process of mixing and the recasting of a 1s, 3p and the 3d atomic orbital of a same atom having nearly same energy to form a 7 Sp3D3 hybrid orbital with equal energy, identical shape and a definite orientation in a space. Now this process is called as an Sp3D3 hybridization. Now in this process the 1s, 3p and the 3d atomic orbital combine with each other to form a 7 Sp3D3 hybrid orbitals. If we consider the geometry for the Sp3D3 hybridization, the geometry is pentagonal bipyramidal. The bond angle is 72 degree and the 90 degree. 72 degree is in a plane, while the 90 degree the hybrid orbital which are above and below the plane. The example is IF7. Now here you can observe in the diagram, out of the 7 Sp3D3 hybrid orbital, 5 are arranged in a one plane, while the remaining 2 are above and below the plane, which leads to the formation of your pentagonal bipyramidal geometry. So this is about different types of the hybridizations that we have observed during the formation of a hybridization process. So now in the next lecture we will going to discuss how to write the geometry for the different molecule on the basis of the hybridizations, which involves the different types of the steps. Thank you so much for watching this video. See you in my next video.